All right, so what we're going to do is just continue on. We're going to say slope notes continued.
Wait, are we adding on to the notes?
No, this is just to make sure that you got these. So if you guys share something with me that you didn't personally write down, add it in. Okay? And then if there's something that nobody shared out, then I'll make sure that we get this key piece of information in. Jason. Yes, Jason Mariner, you may go to your locker and get your math notebook. Not that I'm recording this or anything. Somebody else have a question? Okay, comments. What are some things that you guys wrote down that we didn't write down in our original set of notes due to time? What's one thing, Spencer?
Positive, negative lines, and vertical.
Okay, so we actually have different types of looking slopes depending upon whether we have a positive slope and negative slope. And then we have these weird slopes when it comes to horizontal and vertical. So there was a set of 4 pictures. That set of 4 pictures should have been added to your notes. So that's the first thing I want to write down is types of slopes. So for this particular exercise, I'm not going to be super fancy with my graphs other than to label them X and Y, the axes. I'm not going to put numbers in them. Gosh, I think I wrote the first one too big, but that's okay. We'll make it through. So the first is, what if you have a line that is pointing, it's got to be somewhere in that first quadrant, okay? In terms of the arrow cap, has to be in the first quadrant. What kind of slope do we say that particular line has? Just generically. Maggie?
Positive.
So that's your positive slope. Okay, so slope is positive when the arrow cap is somewhere in the first quadrant. Okay, so we're looking at the upper arrow cap. Okay, that's kind of my clue. All right, so what if we have a line that looks like this? So now the upper arrow cap is in the second quadrant. Josh? That's called a negative slope. Okay, and then what if we have this line? Okay, so first we need to identify what kind of line he is. See if we can remember how we would write his equation, and then what kind of slope would that guy have? Okay, so first off, what kind of line? And don't say straight because I know that's true. Brian?
Horizontal.
So we have a horizontal line. So we got a lot of information to write about this guy. Horizontal. Can somebody tell me how we generically write the equation of a horizontal line? Just generically. Ethan? Okay, hold on. That's not the question I'm asking. Okay, how do we write the equation of a horizontal line? Patrick?
X equals 0.
All right, let's try this again. When we write the equation of horizontal and vertical lines, it doesn't look like the equation of a line that has a positive slope or a negative slope. Because in the positive and negative slope lines, there's an x and a y in the equation. But with horizontal and vertical lines, there's only one variable allowed. So what's the variable that we're allowed to have with a horizontal line? And hint, hint, look where it's crossing. That tells you how to write it. Serena? Yeah. So this is going to be y equals, and then I'm going to use the number symbol. That's not hashtag. And it's whatever number that we cross out. And by the way, that number is the y-intercept. Now, the slope of this line, however, what is the slope of a horizontal line? What did you get, Maddie?
0.
It's 0. So slope is equal to 0. Because it doesn't matter. Remember, if we do rise over run, I'm going to have a y number over an x number. And in the y number, it's always the same. It's the x number that can change. So if I take a y number and subtract it from itself, I get a 0. So it looks something like this when I'm doing the formula. I end up with getting something that looks kind of like that. And anytime I take a 0 and divide it by a number, I get a 0. Okay? All right. Then we have one more. Okay, so what kind of line is this guy? The purple one. He's vertical, okay? And if I write his equation in general form, what would that equation look like? Allison? It's x equals some number. That number will be the x-intercept where it crosses the x-axis. Now here comes the intercept. That's a C, a very lousy C. And then what is the slope of a vertical line? Okay, slope of a vertical line. Aiden.
Unidentified.
Okay, we're going to use a better word for that, but you're right. It's called not unidentified, but undefined. Okay? And the reason why it's undefined, I'm going to put it up here, is that if I'm doing slope formula and I have different y's but the same x over and over again, I'm going to get the difference between the y's on top, but the difference of subtracting a number from itself gives me a 0 in the bottom. And that is mathematically something that we don't know how to do. It's the one thing that we'll never learn how to do. So I do want to make a correction, something I heard Ethan say. And our book uses this, and we need to get rid of it. And it's the phrase, no slope. The reason why we cannot use that is because I have kids that say 0 means no slope. And so they get confused by that term. So physically, the slope is 0 with horizontal lines. But with vertical lines, we're going to say undefined because mathematically we can't explain that. So I know the book is really bad, and it shows you that no slope. Throw that out of your vocab. I will not give credit to anyone who says no slope. What you need to tell me is undefined slope. Does that make sense? Okay, good. Anything else that you guys came across when you were doing your notes that we need to add? Anything else that showed up in your notes that we didn't get to write the first day because we had a short day? And by the way, 6th period had like nothing because we had the drill. So that was kind of a interruption not anticipated.
Was that a drill or was that?
You know what? I found out after the fact it was actually a planned drill, but they didn't bother to tell us. I know, that was kind of not good. See, nobody knew about it. They forgot to tell us. So, anything else? Okay, so let's just recap. You started calculating slope using a graph, finding 2 points. Oops. And, no, this is a recap. If you should have this already in your notes. And you counted how much you rose to get from one point to another, and I always rise up because I'm always going from the bottom point to the top point. That's just my pattern. And then you run either right or left, whatever it takes. Now, rising, if you're going up, it's positive. If you're going down, it's negative. Running, if you're going to the right, it's positive, and if you're running to the left, it's negative. So the directions you're moving actually include a sign. So that's how you guys used to do it. But the problem was you needed to have a graph of a line with 2 points having integer coordinates. And as hopefully you guys are understanding, life isn't perfect. It doesn't work out so neatly in a nice little package. So that became a problem. Plus, it takes a lot of time to make sure that you're graphing and then trying to figure out all that other stuff. Because if you think about it, let's say you're given an equation. First, you're going to have to create a chart, come up with 3 points, graph it, and then trying to figure out rising from one point to the other and running, it just crazy. So then we morphed the formula, and we said it's the difference in the y. So again, you guys already have this, but if there's something you didn't write down that you want to add to your notes, over difference in x's. So it's rise goes with y's, rise y's. and run. You can only run across a flat surface. Well, you can do mountains, but it doesn't feel good. Without effort, let's put it this way. And then we said, okay, well, if we have our 2 points, and we're just going to generically call them x sub 1, y sub 1, and x sub 2, y sub 2, we could translate the difference to actually be a subtraction problem. Oops, sorry. That should be an x. And that's how we now are learning how to calculate slope, is actually through mathematically taking 2 points and subtracting them. The key thing to remember, above each other should be coordinates from the same ordered pair in both cases. Okay? Aiden.
Wouldn't it be like y2 minus y1?
You can do it either way, as long as whatever y coordinate you started with, you start with its matching x coordinate. That's the key right there, is it has to be one above the other, has to be the same ordered pair. So in this case, here's my second point, and here's my first point. Okay? Any questions about the slope? Ethan?
So if there was a line, where would, like, if you wanted to find its points, where would you start? Like,
You're going to find 2 points. You're going to find 2 points that cross at the intersection lines of the graph paper, so that you have integer coordinates. And then you get to determine whether to go from the bottom point to the top point, because your 2 points aren't going to be this way, straight across from each other, because then you know it's a horizontal line and you already know the slope. Okay? So you're going to either start with the bottom point and rise, run, find the top point. So you can do it that way and call this x1, y1 at the bottom and x2, y2 at the top. Or you could go from the top to the bottom. It doesn't matter. Okay? That doesn't matter. Because we're not counting with rise and run, we're actually calculating with our formula. Okay? All right. If that's it, I'm going to close this one out. Good luck with this.